So, first things first, right? Let's go over with what will be on the exam, since that's probably like the number one thing, right, that everyone wants to ask. Okay, you should be able to see my screen. All right. So, first things first, what's going to be on the exam itself is pretty much everything that you've learned over the semester. So what does this include? Well, there's going to be Gödel numbers. There's going to be a lot of regex. It's definitely a key topic. There's going to be a lot of grammars. Definitely another key topic. Automatons. And the reason that I star these three is because if you've noticed from exam 2, all three of these topics have made an appearance even with Pumping Lemma. Because you can choose to either create the language or prove why it can't be created using the proof. So because of that, these are key concepts for both exam 1 and exam 2, and there's going to be a lot of them for exam 3. On that note, Pumping Lemma definitely is going to make an appearance. For sure, Turing Machines, right? Usually those like algorithm questions as well, like, you know, the part D's and part E's that are usually on the like questions. So those are usually a little bit smaller of a part, so that's kind of why I don't usually go over them as much. I usually try to focus in on the big point questions, like with Turing Machines and Pumping Lemma. And then finally, the only new topic that will be on this exam that you have not had on the last exam is Pushdown Automaton. Otherwise, this is what's going to be pretty much on the exam. So, before we kind of get started, does anyone have questions about the topics that are going to be on the exam? Okay. So, if you guys have specific topics that you'd like to go over, let us know. We can go over really any of this stuff. It's gonna probably all appear in some way on the exam. Again, I'd say these 3 star topics especially. But there's definitely gonna be probably at least one of each of these kinds of questions on the exam, I would argue. And with that being said, you can kind of like pick and choose, you know, which that you're better at. And there's going to definitely be more points as well. Meaning you need more points to pass, but there's going to be way more points for you to actually be able to answer. So even if you need, instead of 40 points to pass, maybe you need, I think you need 60 points to pass, which sounds like a lot, but expect something along the lines of like 150 points or so on the entire exam. So you could literally pick and choose your topics. Like if you want to do like regex, grammars, and pumping lemma, like go for it. Like you should be okay with that. So that's what's really good about with the final exam and why most people say the final is easier. There's a lot more stuff from exam 1 that's a little bit easier, and while there is a lot of content, you get to really pick and choose.
Will we be given more time for the final?
Yes, so I think you're given the full 2 hours. But of course, you know how Professor Obernick usually spends some time getting everyone into their seats and everything, so expect a little bit of a delay, but you will definitely have more time to answer the questions, but you will also have more questions too, so it still might feel a little tight time-wise. Okay, so, yep.
Hi, Professor. Professor, so for the exam 3, the full the full score of the full score of the pod score for the exam 3 gonna be 60 out of 150.
Give or take, yes. I don't have the exact scoring because, of course, every semester the exam and the points tend to change, but expect it to be something along those lines. You're definitely going to have you need to get more points to pass, but there's going to be way more questions. So the percentage that you need to pass is still going to be very similar.
Okay, okay, I got it. Oh, thank you.
Yeah, of course. So with that being said, this is open to you guys. So you let me know what topics you want to work on. Put some questions in the chat, and we can do that. Otherwise, if not, during a tutoring session earlier today, I had a request to do a Turing machine question. So I'm probably going to start with that while you guys find some questions to post in the chat. So if you want to take a picture of this, now is your time to do that. Because again, this is like definitely, this is everything that's going to be on the exam. So you want to make sure that, you know what's going to be on the exam. But yeah, any of these topics, feel free to post questions on in the chat. We can go over whatever you guys like. And you can also ask general questions in the chat as well. Rashawn is in there, and she'll be happy to answer those questions for you. In the meantime, let me pull up the Turing machine question. All right, so Turing machines are often a topic that is probably one of the more difficult topics, I would say. A lot of students have trouble with them, and the main issue that I would say is because of the difference between going left and going right. And this is a great question because it does just that. It goes left and it goes right. So for this, right, we're going to practice a little bit on how we're going to actually create these regular expressions that come from these Turing machines. So first things first, right, let's see what's kind of going on here. I have a bunch of states over here. I know I'm starting in state Q, and my final state, F, is state S. My sigma, meaning things that I'm reading on my tape, is A, B, and C, and my tape itself can write the following: a blank, lowercase abc, and capital ADK. So this time around, not only can we read and write lowercase letters, but when we write a letter, we can write a capital letter. And that means that if we end up going backwards, we can actually read one of these capital letters. And we'll notice when I do the rest of the problem, I equate this to going over an exam, right? You write out all of your answers, and then you go backwards and read over your results and make sure you check your work and it works all good. So that's kind of what we're doing here. We can think of the capital A, D, and K as like our answer choices that we're going to see. So I need to get accept, reject, and diverge. Accept meaning I get to state S. So where is state S? Well, I can get to it here and here from state T, and that's it. So I know that I have to go to state T. How do I get to state T? Well, I know I have to go through state W. Right? That's the only way I can do that. And how do I get to state W? Well, I need to go through state V. And how do I get through state V? I need to go through state Q. So just like that, I traced backwards a bit and I found the route that I'm going through. I often tell students that when they're first doing these problems, draw them out as an automaton first. Because it kind of helps to see like what's going on there before you actually draw it out as a tape. But in the essence of time, you might not have the time to do that during the exam, so it might be better to kind of learn how to do it via the tape. But for the time being, we know that we're going from Q to V to W to T to S, right? This is kind of like what's going to be going on over here. So we have over here, we're starting out in state Q. So I'm going to draw out a tape over here for us to see what's going on. In state Q, I have 3 choices. Each of them brings me to state V. I can do A, B, or C. So this just simply becomes A or B or C. It's just one single character. Now, I see over here, right, that I'm going to be writing something different to my tape. So if I read an A in the beginning, I'm writing a capital A. If I read a B at the beginning, I write a capital D. If I read a C in the beginning, I write a capital K. And the reason that I'm keeping track of this is because when it comes time for us to move to the left, we need to realize that once we get to this point, we are no longer reading lowercase letters. We're reading capital letters. So that's going to help us later on. So now that we're in state V, what's going on in state V? Well, I can loop on state V if I have an A, a B, or a C. So this just simply becomes A or B or C star. And this is just a simple loop on V. I can do this as many times as I want. But now, once I'm finished with that, I have a special state over here that takes me to a blank. But notice, this is not your ordinary diverging state, like this one over here that has blanks to the right. This time, we're doing blanks to the left. And the way that I look at this is I'm going to put a blank down. And this is like a period at the end of a sentence. This marks it off. This is the end of my string. And now it's time to go back and check over my answers. So from here on, I'm looking to the left. And now, right, we know, what did we write? We wrote A or B or C, and then A or B or C star. This is a very vague answer. That's why we need to go back over it and fine-tune it a little bit, because there's still so many more states that we have to go through that this needs to be able to handle. So let's take a look at what happens when we enter state W from the left. So this time, right, I'm going to just draw a continuation of the tape, since now this time we're looking to the left, right? This is what we're overwriting with. So now I'm entering state W from the left. What am I looking at? I'm looking at the very last character that I wrote. This last character, I'm going to actually change colors so we can clearly see that we're looking in another direction. This comes from this part over here, A or B or C star. Remember, I have as many characters as I want from this. I could have as many A's, B's, C's. I really don't care. It does not matter what I wrote. I just take a character from here, and this is the very first character that I'm looking at when I'm in state W. So let's see, what does state W need? Well, first things first is I see that if I have an A, I loop back onto W. If I have a B, I go to state T. which I'm going to need to get to state T in order to get to state S. So this is going to be very important for later. But we have to consider all the possible states. Then if I have a C, I have an X transition over here. Now, looking forward, X is not really going to help me because X gives us kind of an infinite loop over here that leads us to diverging. And the reason I say this is because if I do X, all of these guys loop back onto X. And eventually, when I can't take it anymore, I just end up diverging. This will help us on the diverging regular expression, but it's not so helpful right now. That means I need to avoid this one and this one. These two bring me to state X, which is no good. Those are good for diverging, not good right now for accepting. So these two are the only things that I can take into account. I don't want to move to state T just yet because I do have a looping state over here for W. This is important to keep in mind because remember, we want to take into account every single possible string. It's like you're playing a video game and you're trying to backtrack a little bit and try to get every single treasure chest that's hidden before you move on in the story and move on to the next location. So over here, I know that if I'm looking at the very last character, this has to be A star. And the reason I say A star is because notice that for both of these guys, I'm moving to the left. So every single character that I take from this part is going to be moving towards the left. So instead of having all my A stars before my B to move to the next state, it's the other way around. I need to have all my A stars after and then have my B here in order to get to my next state. Because again, I'm looking this way. What's the first thing I see? A star, then the B. Otherwise, if I had the B, then I would change states and this would be completely useless. So with that being said, right, I know I have to have A star first, and then also from this chunk, I can also bring down the B. And this B is going to get me from W to state T. So to recap, we had a W loop coming from the first A, and then we had a W going on to T if we had a B. And all of these guys just came from A or B or C star, because remember, I could take whatever characters I want, but now going through more different rules, I know I have to be a little bit more picky. So continuing left, right, because that's what our Turing machine's telling us to do, we're entering state T from the left. I know that I'm still looking at some character around here, right? Technically, it could be in here or it could be in here, right? Because again, the only differentiation between these guys is the leftmost one writes a capital letter. And so far, I haven't read any capital letters yet, so for that reason, I'm assuming it has to come from here. Since this is just literally A, B, or C that I'm writing. Just the usual. So in state T, I finally have found how to get to state S. I have two choices. I could have a C or I could have a K. Notice we're reading in a capital letter. This could mean only one thing. We've gone back so many times to the left, we've made it all the way back to state Q. That is the only way that I could have a K. But whether I choose to go all the way back and have a K, or get my C somewhere around here, they both come from reading in a C. Whether the C is here, here, or really anywhere around here, between these two guys, it's totally fine. It's not being that picky. Sometimes they are being picky. Sometimes this would only accept if this was a K. If that was the case, then you'd have to keep that in mind. But because of this, right, all I know is that I need a C somewhere along this regex, right? And that C can either come from here, or here. Right? Otherwise, we really don't care too much about what's kind of going on here. For that reason, right, at this point, we've determined what our regex is going to look like. I know I have to have a C either here or here. And I know I also have to finish off with a B here and an A star here. So let's trace over what this is going to end up looking like. We have two different cases that we have to keep in mind. The case where the C comes from the second part and where the C comes from the first part. If I choose the C coming from the first part, I know I have a C here, and I know my last two characters at the very end must be a B and then an A star, right? Because again, when we went to the left, we saw this has to be a B, this has to be an A star, right? And now if I continued going to the left, right, A star, B, right, this would bring me to state T, and the only way I could accept is if I have a C. So with that being said, actually, I can't have anything between this because I can't accept anything in between this. Once I get into state W, I must have an A, a B, and then a C in that backwards order. Otherwise, I can't accept. So that means that this C would need to be moved over to over here. So this is going to go for whether or not I do the first part or the second part, right? But the key difference here now is going to be, well, I know I have to have a C and a B and an A in the beginning, but what about if this C was not the first one? What if I had something else here? Like the A or B or C coming from here, or other A's or B's or C's here. Technically, I could have cut it off right here, and there's still some good letters all within here. Well, if I did that, right, that means technically I could still have any character I want in the very beginning. The very minimum, though, that I need is a C, a B, and then an A star, right? And this will allow me to get that accept at the end. So this might have been a little bit confusing at first, but the main trick is we drew it out, right? We knew that it came from this very vague regex, A or B or C, mandatory, and then A or B or C star, not mandatory. We traced backwards since we reached the end, and we saw, okay, I can loop on the W state on an A, but then once I want to get to state T, I need a B. So I'm working backwards. There was an A star that came from this, a B that came from this. Now that I'm in state T, I need either a C or a K. Well, we know that a C can either come from here or here. If it comes from here, right, technically there could still be more characters before it. That's why we have to include this optional A or B or C star beforehand. But at the very minimum, if I have C, B, A star, I'm good. My L accepts. Questions? Did I lose people?
You explained it very clearly.
Okay, I'm glad to hear that. All right, let's move to diverge and then reject. So now that we worked out the main gist of how this Turing machine is structured, right, we can go a little bit faster through the other parts, right? Because we know exactly what this thing looks like, the structure for it, and the regex. Now we just change our destination. So diverging is usually the easier of the two that are left, let's say. Accept is usually easier, diverge is usually easier, reject is where it usually gets a little tricky. So I say focus on the accept and diverge first, and then maybe move to the reject if you have time. Focus on whatever's easier for you. Maximize your points. So as I said before, we're looking for when we have blanks to the right, not blanks to the left. Blanks to the left are like a period at the end of the sentence. It has to be blanks to the right. And the only way we can do that is if we get to state X. Those are the two that I actually X'd out before. So now those are our destination. So looking at this quickly, right? If I draw another tape, I know that to get from Q to V is the first step. I have to have A or B or C. Then I'm in state V, and state V allows me to do A or B or C star. I put a blank down at the end here, and this is like a period at the end of a sentence. This is not diverging, right? Diverging is when I have blanks that go on forever. This is not blanks going on forever. This is clearly the end of a sentence. This is, as I say, it is really just the period at the end of a sentence. So because of that, I know this is the end. Diverging means that it goes on and on and on and on forever. I'm constantly reading and writing blanks to the right. This just puts one blank down and moves to the left. Now that I'm looking at the left, I'm in state W. Right, this does V loop. Now I'm in W. Okay, so just like before, right? Before I move on to this X over here, I can still do an A star. That's totally fine because that still keeps me in state W. This is like a little loop on W. But now I do not want a B. If I have a B here, that brings me to state T, and that's going to bring me into an issue because now I can choose to accept at that point. And this is going to be diverging. So what do? I just don't have I don't have a B. So what is my choice then? Well, if I don't want a B, then this has to be a C. So just like before, notice that I can choose a C or a K. Just like over here, I could choose a C or a K. The difference is I don't have that B sandwiching them between each other. So once I have that C, I go to state X. And what's going on in X? Well, notice that I'm looking now towards the right. So now I'm switching again. So once I look C, right, I write my C down, and now I'm looking to the right. So now W has changed to X. So what am I looking at? Well, I know that my regex allows me to have A star. But this actually allows me to do three things. I can choose to loop A, B, or C as many times as I want. But we know that doesn't work because we defined this very specifically as it can only be A star. If I have a B there, we have a problem. If I have a C there, I have a problem. I can only have that A star there. So for that reason, right, we must have this stay as A star. And this is going to allow us to still abide by the property I set here. So even though the opposite kind of happened here, right? Because the first time we did this, we wrote our regex extremely vague and we got more specific. The other way around, we started off very strict, only A star, and now this is telling us that I could have had A, B, and C star. Well, the strictness is what's going to win in the end. So even though this says otherwise, we can't listen to it. We've already made rules, we must follow them. So we know that we have to finish off with only A stars. And eventually, this diverges, right? I can choose at any point here to just start doing blanks. And this just diverges on forever. Notice blanks to the right, not blanks to the left. So how does this change? Well, just like before, I know that at the very minimum, I need C, A star. Just like over here, I needed C, B, A star. So the only thing I'm missing here is just to include the fact that I could technically have anything I want beforehand. I just have to have that CA star at the end in order to allow me to get to state X. So my final regex for L diverges is just simply going to be A or B or C star, C, A star. Right? And that's what we have down here in the answer as well. So this is going to allow me to get to state X. And if you notice, they're very similar. The only difference really comes down to that 1B. Okay, now we get to L regex. This is where it gets a little bit more difficult, but we can still do it. We need to take into account that there's a lot of different cases here in which we can choose to accept and diverge, right? Oops, I meant to erase. What the heck? Technical difficulties. Well, that's not working either. Okay, so we're just going to have to tolerate the marks then. So in a case like this, right, whenever we have regex, L regex is essentially every single thing, every single string that you can make, subtract the L accepts and subtract the L diverge. It's everything that doesn't accept or diverge. Everything that doesn't fit in the bucket, basically. So, first things first, before we go any further, I have to avoid any state that accepts or diverges. That means I cannot go to state S, because that's my accepting state, and I can't go to state X because state X has a diverging state within it, right? And by default, once you're in a diverging state, you can technically diverge at any point. So we don't want that either. So I have to choose a point in which I want to get stuck at. I want to find where I can break this. So I know I could probably break this in state Q, right? There's no diverging states, so I could technically break this. And the way I could break this is by having no input at all. Notice I have an input for A, I have an input for B, and I have an input for C. What if I just had nothing? What if I had a lambda? That could work. I could totally just have a lambda, and that would break it in state Q. Okay, cool. Now I got to continue and say, how can I break it in state V? Okay, well, state V now is going to be a little different, right? First things first, I need an A, a B, or a C in order to get me into state V. So for here, I know I have to have an A, a B, or a C. And this is going to get me from Q to V. In state V, technically, I can't really stop at this point because if I were to stop, I would just default go to W. Since this blank is saying, okay, you got nothing left, stop and go to the left. So technically, I still have to do state V. I can't really stop here. It's like a no standing zone on a bus stop or something. You literally just can't stop. So this is just going to be V star. All right, so I can't really stop there. But this gets me back to W now. Can I stop in W? Well, this is saying I'm looking to the left. And towards the left, I see that I'm going to always have a character there. And I have a case for A, B, and C here. So this is a bit of an issue. But what do I not have here? Well, what if I didn't have this star part? I would only have this part here. And the first part right? We know it doesn't write lowercase letters, it writes capital letters. And I only have a case that can deal with a single K. So this gets me thinking, that means if I only had a single A or a B, meaning I just said skip this V, which I can totally do, it's a star, who cares? I can totally skip that, right? I can just say, all right, well, I can just say have a B or a C coming from this, right? And this would totally break it. A single B or C, that can cause some problems. So that's how I could break it in state W now. Okay, so that's another case I can keep in mind. So if I'm writing all of these different cases down, right, we know we had our lambda. I can do a B or I can do a C. What else can I break it with? Well, let's say I continued onwards. So I did A or B or C star, right? And then I went to the left, and now I'm in state W, and W says that I can do A star, right? And then if I choose, well, I have to stay away from a C or a K. Because if I do that, then that means, oh, actually, I'm sorry. This should actually be not B or C, because C would give me a K. This should actually be A or B. Right? Because C would give me a K, and K we have a case for. It's A and D that I want. So in this case, now I'm looking to the left, right? I'm in state W. I could do A's, that's fine. I don't want a C or a K, but I can do a B, right? I can have a B, that's fine. I just can't have, going to the next state, T, the second I have a C here or a K, I'm doomed. I just can't have a C or a K here. So this part here has to be an A or a B. If it's an A or a B, then that's totally fine. So this is going to end up looking similar to this now. I can do whatever I want in the beginning. And I know I have to follow A star and B at the end. But here is where I would have had to have a C. Right? Now, just don't put a C there. Put an A or a B in there. And that will break it. So
why is the A star in front of the B?
A star in front of the B.
Shouldn't it be, like on the right side, shouldn't it be A star, then B?
So the reason is because we're going to the left. Instead of looking like this, right, we're looking from the left, so I'm going in this direction.
I get it. I see now.
Yeah, I see A star, and then I see B. So for that reason, right, this is what that part would look like. And now that is going to be the last case in which I can break something, because I know that the only other case I didn't consider was X, and we know that can't be because I can diverge there. So put it all together, and what does this look like? Well, I have lambda, or A, or B, and then I have this case over here, A or B or C star, A or B star, B, A star. And this is similar to her answer over here, except technically, I see you don't exactly need the lambda, right? Okay. I think my answer would probably work as well. I had just the stars in different places in that case, right? But technically A star could work, right? Since technically, if we had only A's, that would definitely break it, right? We know that if we had only A's, that would definitely break it, and that's the same reason why if we had a single A or a single B, we know that would indeed break it, and the star implies a lambda, right? Because star could be 0 times, and this could just be an empty string. That's why it's important to kind of keep in mind whether you have stars or not for the lambda. Then for the second part, just like before, I could have whatever I want in the beginning. I know I have to have like I know I have to have a B and then an A star at the end because that actually gets me to state T, right? And state T is where I want to break this at. And state T now, that is where I can choose to do an A or a B as many times as I want. So I say the star could work for this. Because essentially I can choose to do it as many times as I want. Although, to be honest, I could also see how I can just do it this way as well, because if I wanted to, I could just have this once, because I'm only looking to the left once. So maybe the star would be a little overkill, and if I wanted to do, I could just kind of put it in here instead. But I think even if mine is a little overkill, I think it would still work for the most part. The main point is that you kind of understand what's going on here. We want to try to see what can I do, what are all the cases in which I can break this at every possible point that does not accept or diverge. And we know that came to having a case at Q, a case at T, and yeah, just pretty much a case at Q and a case at T, and actually a case at W as well. So that is Turing machines in a nutshell. So sometimes they'll ask for regex, sometimes they'll ask for strings, right? The strings are extremely straightforward. If you have the regex, you can just make the strings easily. So I'm not going to go over that because you can just essentially make it as simple or as difficult as you want it to be. We have two of these algorithms questions. Let's see, the answers are here, so let's actually take a look and analyze why they are the way they are. Explain how to construct an algorithm that solves the following problem. If such an algorithm does not exist, state that it does not exist and prove your claim. Turing machine that accepts a set S by final state. Is S regular? So, this algorithm does not exist. If it existed, it would decide the set of Turing machines whose language has the trivial property is regular. I think this is coming to the fact that because even though we can essentially write a regular expression based on this, let's say this property is non-trivial since it is true for 0, 1 star, but I'm going to be completely honest, I'm not really too sure on these algorithm ones. Yeah, I'll be honest, I kind of say skip them for that reason. Some of them can usually be a little bit more straightforward, but this one seems to be a little bit not so straightforward. The main key is if you understand the accept, diverge, and reject cases, then you should be totally fine. Okay, there's a lot of stuff going in the chat right now. Questions about what keywords do I need to catch to determine given a language is regular or context-free? Okay. All right, let's take a look at some of these then. Yeah, Rice's theorem's a bit tricky. Rishan, do you have an idea on that question, by the way? Or we could just move on to the next part, if not. So if not, we can just move on to the next part. Okay, so I think most are not regular because most of them are non-trivial. Okay. Yeah, it kind of seems to be like that. Like, a lot of them don't seem to have a trivial property that can be written as a regular expression, but if I'll be honest, I'm not 100% sure on that. So this has always been kind of like a weak spot of mine. So I'd rather kind of just spend the time on the stuff that, like, I know I could definitely help on. So let's go over with pumping lemma basically when to know whether it's regular or context free, right? So whether you like pumping lemma, whether you don't like pumping lemma, this is extremely important because if you like pumping lemma but you don't like regex and grammars, well, guess what? If you know when it's pumping lemma, you can do the proof instead of that. And on the other hand, if you don't like proofs and you know when it isn't pumping lemma, then you can just construct the language, right? So for those that like, for especially exam 2, like there were some students that didn't really go over pumping lemma very much, and honestly, it's okay. Like if you're just someone who's not so proof oriented or you wanted to focus on the other things, like you can honestly get away with that because there's going to be questions that do involve pumping lemma and don't involve pumping lemma, even if they do end up kind of looking like that, right? So when we're looking at these types of questions, right, the key to know is if it's regular, there can't be links. The second there's a link, it's not regular. For context free, I always say there's 2 cases in which it can't be context free. First of all, links of 3, not context free. And it rhymes, so hopefully that'll help. And then also, links in between, not context free. Okay, so what does this look like before we get into some examples? What is a link? Link. They both have the same exponent. It doesn't matter that this has a 2 and this doesn't. This is saying that there's double the number of B's to A's. This is immediately not regular. This will become your characteristic property if you're looking at the proof. And all you need to tell is that there are going to be twice the number of B's than the A's. So for every 1A, there's going to be 2 B's. That immediately tells you that it is not going to be regular. Links of 3 speaks for itself. Links of 3. Your pumping window is not going to be big enough to pump this, right? You define a pumping constant at the beginning of the proof. Usually it's like beta or something. And essentially beta is always going to be less than the length of this string. And the whole reason that this is going to be a problem is because I literally cannot stretch this all the way to the 3rd segment. I can do 2 segments here. I can do 2 segments here. I could choose whichever 2 segments I want that are consecutive, right? I cannot reach it all the way over here. It's just not big enough. It's like trying to wrap a really small towel around you. You're not going to get dry. Now, in a case where it's links in between, we have intersecting links here. Notice there is links in between. This guy is stuck sandwiched between these 2. So if these 2 get pumped, guess who also gets pumped? B. And then that means this B gets pumped, but this B does not get pumped. So it's like your friend decides to watch the next season of your favorite show without you. You're going to get very upset. So this guy watched the show, and this guy did not watch the show. And that was all because B was sandwiched between A and C. Maybe he watched the show against his will. Who knows? But these are your cases. And when you get a problem like this, you're probably thinking, oh, well, this is not like your normal telescoping grammar, which sometimes it will literally look identical to one of these. And if it does, that's great. The answer is literally right in front of you. But sometimes you have to do a little digging, and that's all right too. Sometimes it might be a little bit trickier. So in a case like this, problem 6 is saying, let sigma A, B, C, G, and let L be exactly those strings over sigma that satisfy all the following properties. Symbols in the string occur in alphabetical order from left to right. Okay, so wait, is this... So I don't know if this is going to be, if this is proving if it's regular or not. It doesn't say, but honestly, doesn't really matter. We can go through it both ways. So immediately, right, I'm going to start by saying if I can prove it's regular, right? Because remember, if I can prove it's regular, by default, it's also context-free. Because again, if there's no links, I could still write a context-free grammar on that. That's totally fine, right? We've written grammars based on regular expressions like a million times. That's totally fine. The key here is the second I have links, it's no longer regular. And the second I have these bad links, then it's no longer context-free. So alphabetical order, not a problem. I can make a regex like that. All the A's, then all the B's, then all the C's, right? Something like that. That's not an issue. Don't have to worry about that. The number of A's is greater than the number of B's. Oh, we hit a link. That's a link. And the reason for this is because even though it's not necessarily defined, right, we know that the number of A's has to be greater than the number of B's. So as a sample link, right, for like a characteristic property, it would look similar to something like this, right? So the second I see something like this, the number of A's, oh, I'm sorry, this should have been the other way around, actually. Right, this clearly defines a link between the two. This one is always going to be greater than this one. And because of that, right, how am I supposed to control that in a regex? I can't. We have a star. Stars are 0 or more. I can't just say, okay, you star are going to be bigger than this star. Stars aren't going to listen to you. So because of that, this immediately causes a problem. Not regular. I'm going to actually change this first one to a check mark to say that that's totally fine. This means that it's not regular. But this would still be fine if it's context-free. This is a link between only two things, the A's and the B's. It's not like saying the A's are greater than the B's, which are greater than the C's, and on and on and on, right? That would be a three-way link. That would be a problem. But in a case like this is not a problem. Then the next property, at this point, right, if you were asking if it's regular, you'd stop at this point. You would make a decision. If I want to prove it, maybe I'm good with Pumping Lemma, and I know immediately, okay, I got my context, I got my characteristic property, I got my proof handy, I'm going to prove it. Maybe you want to do that. Or maybe you step away at this point. That's totally fine either way. Now, if this was asking to prove if it was context-free, at this point, I'd still be fine though. So now the total number of A's and B's is equal to 4. So this over here is still going to be fine. We've done a couple of these before in which we didn't really have, like any problems in a sense, right? I can just say A, right? Boom, they're equal to 4. Or technically, right, because it's A or B, A or B, A or B, A or B, A or B. And I just have a set of these, and the group is always going to be in multiples of 4. Okay, that's totally fine. Check you off. The number of C's is divisible by 3. Number of G's is divisible by 4. Same exact reasoning to this. So we're not even gonna go through that. So for this reason, right, the only property that causes a problem is this second one if we're proving it's regular. If we're proving it's context-free, guess what? You are free, haha, see what I did there, to draw your context-free grammar. So again, you make that decision. If you like Pumping Lemma proofs, look for the proofs. If you hate Pumping Lemma proofs, look for them and avoid them at all costs. All right. Let's take a look now at the second one. I don't understand when they say divisible. Are we dividing the number of letters with 3 or 4? Yeah. So we've done these before, right? This is kind of, actually, this was pretty much what I had on the screen here, right? It doesn't have to be A or B. It could really be anything. This is divisible by 4 because, notice, every time I'm spawning these guys with the star, it's always in a group of 4. So because of that, right, this is always going to be divisible by 4. Go back to the even and odd examples. If I wanted an even or odd number of A's or B's, boom, it's even. 2n. Every time I iterate through this, it's always going to be in multiples of 2. If I wanted odd, 2n plus 1, A or B. Add another 1 there. This is extremely important, and honestly, if you should probably like commit this thing to memory over here, because I can probably bet you that there's probably going to be an even versus odd question somewhere along here, right? And it's important to know the formula. 2n plus 1. And I could do this with anything. I could do this with single characters. I could have said G, G, G. Now the G's are odd. Now the G's are even. So I can do this as many times as I want. I could do this even, odd. I can put as many things as I want in here to make it divisible by whatever I want it to be. Okay, that's another little formula. We got our little reference sheet going on over here. Too bad the exam's not allowing you to reference sheet. Gotta put this in your memory. Okay, in the question, there are 4 letters, so it won't be divisible by 3 RT. So that's a good point, but notice the total number of A's and B's is equal to 4. But the total number of C's is divisible by 3 and G's is divisible by 4. This is going to be a tough grammar to write out. There's going to be a lot of steps, but the way I'd approach it is break each of these guys down into their own function. The number of C's is divisible by 3, right? All right, if I were to draw out regex or grammar. Well, I guess this is not regular, so I might as well do a grammar. Let's give it a shot, right? Divisible by 3. 1, 2, 3. Then I call a function, let's say function A, and I have a lambda, right? So every single time that I call function A, I'm calling it in iterations of 3. And likewise, number of G's is divisible by 4. G, 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 G. Call function B, lambda. So, and then likewise, A or B, right? How would I do that? Well, I can just say it's equal to 4, right? So technically I have to call this 4 times, right? So I need it to be D, 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 right? Every single time I call this 4 times, right? And I'm always going to have an A or a B in here. And what this is going to say is the first time I call this, right, I'm going to say, okay, well, I'm going to have an A or a B, right? So then A, right? Or maybe I called this D, 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 D twice, right? And then eventually, I called it again. And now I'm going to have all A's or B's or A's or B's in all of these spaces. Whatever it would be, it doesn't really matter. The key here is that you can essentially create it without a problem.
Professor, how is this keeping the second property where the number of A's larger than the number of B's though for function D? Because couldn't it just be like more B's than A's?
That's a good point. So I was just kind of giving an example with this, right, for this property here. But if we wanted to make sure that the number of A's is greater than the number of B's, right, then in that case, I would probably need to have something that says that this gets called like twice, right?
Would the only available like strings be A, and then just A?
Yeah, it probably would be better to just hard code it, honestly, instead of doing it this way, because now I'm thinking, like, there's a lot of things here that probably wouldn't work. So I think if I were to just kind of draw this out myself, I would quite literally just draw out every single combination, right? Because again, I can just choose to have, I need to have a greater number of A's than B's, right? So if I had an A here and a B here, right? My A's have to be greater, so that means I'd have to have 3 A's and 1 B. So I can just choose AAAB, AABA, ABAA, BAAA, and make this recursive, because again, it has to be equal to 4. Actually, no, this would not be recursive because I could only have these cases. Yeah, so because it says it has to be equal to 4, if it said it was a multiple of 4, then I'd have the recursive case. Because it's equal to 4, I have to have these cases somewhere in here. Now, it doesn't necessarily have to be consecutive like this. In between here, I could actually choose to put any of my other 2 functions in here, right? No, I can't, because the first thing is saying symbols in the string occur in alphabetical order. So that actually means that the only thing I can do here, this is not in alphabetical order. This is not in alphabetical order. This is not in alphabetical order. It has to be this case over here. A, B. Okay. So you see how all these different rules break it down. Because otherwise it's like, okay, technically in between here I could do whatever I want. Not exactly. So I have to start out with A, B, or technically a lambda, because I could choose to just, wait, no, it has to be equal to 4. It can't be not equal to 4. So this is mandatory, right? Then after this, right, I can choose to have, right, so after my D, then I have to say my C's, and then, wait, what did I use for C's? Okay, C I use the function A for. This is making it way more confusing than I was looking to do, but, and then my G's. Okay, so break this down one more time. D is handling our function for our A's and B's. What is the only case I can do for my A's? Well, I need them equal to 4, according to point 3. The number of A's must be greater than the number of B's. So therefore, I have to have AAAB, right? And because they occur in alphabetical order, no other permutation is going to work. Then,
Is AAA not available?
actually, yeah, that would work too. Never mind. These are really making me think. Yeah, so that was a really great catch on that. So because the number of A's plus the number of B's, right, this is actually fine because this is just 4 A's plus 0 B's. So that's still going to be 4. So that's actually fine too. It doesn't say anything like I have to have B's. Okay, and then after this I have my C's, right, and that's being controlled by this A function here. And then I have my G's, which are being controlled by this B function here. this would be the end of that problem. So in conclusion, we can draw out a grammar for this. It was a little bit more convoluted than it should have been, but it's definitely possible. Where it wouldn't have been possible is if I was asking for it to be regular, right? Because immediately, regular, I could have done everything else regular, but I could not have done the second point regular. Right, all the others, right, we kind of broke down that I could have done something like that, which actually this probably would not have been right for that, but you get the picture, how I could have done something where I grouped them into little pieces together, right? So that could have been done, but because of the property that made a link, the number of A's is greater than the number of B's, immediately, this is not going to be regular. Okay. So let's look at some of the other ones. These are good problems to go over. All right, so the second one, I see the magical word palindrome. All right, let L be the language over sigma that consists of exactly those palindromes whose length is divisible by 4, but the first symbol is C. Okay, so immediately, oh shoot, I think it just disconnected on me. Hello? Can you hear me?
Yeah, now we can.
Yeah.
Okay, yeah, my internet just crashed out. Sorry about that. Okay, good now? You could see my screen and everything, we're good?
Yeah.
Yeah.
Okay. All right, so we have over here palindromes, right? So the second that I hear palindrome, this is usually a red flag. Palindromes, we know, go along the lines of something like this, right? We know that there's going to be links between characters. But here's the thing. If it's a finite number, right? If it's going to be a finite cardinality, I can still do this in a regular expression. For instance, if this was just lengths of 3, I can write every combination of A, B, C, G that is a palindrome similar to this, right? But notice whose length is divisible by 4, but the first symbol is a C. So in a case like this, right, this is technically going to be infinite. And the problem with this is that I can't necessarily control this at this point, right? Something like this is going to be a bit of an issue for a regular expression to handle, right? It's not just going back to simple examples. But I believe you probably could make this into a grammar because palindromes are nice since we have concentric links similar to this. And concentric links are going to allow this to work out quite nicely. So we know that it has to be divisible by 4, but the first symbol has to be a C. So the usual way that we go through these kinds of palindromes is we usually have cases that kind of look similar to this. Right? So every single time that I call a function, I put an A in the beginning and an A at the end. That's why grammars are so good for these things, especially when they're infinite like this. So I know first things first, I know I have to have a C at the beginning and end. It says the first symbol is C, but we know it's a palindrome, so the last one also has to be a C. All right, so now I also know that I have to have multiples of 4. So for that reason, right, I have to have this go through 3 other concentric functions. And the way this is going to end up looking is similar to this, right? I'm going to have my functions. This now, at this point, I can use anything I want, right? This is totally fine. A, B, A, C, wait, sorry. B, 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 C, B, C. And in the interest of time, I'm just going to do this for the C's. Well, okay, you know what? I'll just do it for the G's too. Okay, so at this point, right, we go through 1 iteration, and then we go through a second iteration. Now, the length must be divisible by 4. After 2 of these guys, my length is divisible by 4, right? So at this point, like, I'm pretty much done. So at this point, I can choose to either end this palindrome, right? Or I can choose to keep going. So for something like this, let's see, how should I exactly choose to end this? Okay, so if I chose to end this, it would look like this, right? So why not have 2 cases? One that continues on a new function b, and one that just ends it straight up here. Okay, and then let's say function b now at this point, right? Remember, I need to have iterations of 2, right? So in a case like this now, right, this is going to give me a length of 4 at this point, right, going into b. So I have to call this again. And I don't want to go back to A just yet, because if I do, then I can essentially choose to stop at that point by calling one of these guys down here. So with that being said, I think I should probably make another function here, right? And this next function will let me choose to either okay, it'll either let me choose to do it all over again, right? And at this point, we have these 2 that are kind of linked together, and then otherwise, these 2 that are linked together. Okay. And now at this point, right, I can choose to, should I be able to go back to A at this point? Because technically I could, okay, if I went back to A, I could choose to continuously recurse or go back here and end it at that point. So if that's the case, then I probably would want to have a case in which yeah, I'm a little bit stumped on how to end this one, honestly. Because if I ended up going back to A, the problem with this would have been, okay, I can choose to end this. I could choose to loop back, which is totally fine, or I could choose to end this, which could let me accidentally put 2 of these guys together, which could cause a bit of an issue. So maybe what I would be better off doing is having a case in which, back at the very beginning, I can choose to go to, let's say, a case that lets me go here and end this, right? So I can choose to do 1 and end it there, right? Or go to the next function, and this function would bring me back. So actually, yeah, this is how I think I would structure it. So give me 1 second. Okay. So the problem was I couldn't really find a way to end it correctly. And the reason for that is because every single time that I tried going back to A, well, A could accidentally get me back into this hole over here, where I would have had 2 extra characters, making it no longer divisible by 4. So if I do it this way instead, right, my first character is always going to be a C. And I have 2 choices here. I could either go the recursive route or straight up just end it here by going to E. Now, E is just going to be AA, BB, CC, GG, right? So I'm going to have something that looks like this, CAAC, or CBBC, or CCC, blah, something like that, right? C, C, and then 2 of the same letters in between. Otherwise, what if I want to continue the loop? Well, this gives me permission to do that. I can go to A, right? And now A allows me to do A, B, A, or B, 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 C, B, C, G, B, G, right? If I want to call this again, I can choose to go to B now, right? And B now allows me to do A, B, B, C, C, G, right? And at this point, right, I can now choose to go back and forth between the 2, and I can choose to end once I make it back to A, essentially. So this kind of allows me to flip-flop between the 2 of them to a point where I can basically end it. Actually, wait, hold on a second. If I do that lambda there, then technically I could go from this state here down here and straight up just end prematurely. So instead of doing the lambda there, if I ended it in B instead, okay, you know what? I'm just going to have it end this way instead. So that way it goes between A and B, right? The problem with B, though, is that B adds 2, but I need another 2 added. I already have a function defined that lets me do that. Function E over here. So once I do this, now I can end it because these are terminals. They're letters, they're not functions. This allows me to end it, and now it actually has an end and it will have that property, and I don't have to worry about it looping forever and ruining that property either. So it's always going to be in groups of 2. Okay. I will be honest, these are usually very tricky, as you can see. So they are meant to be the hardest questions in the exam. And if you want to skip them and work on easier ones, you can totally do that. So if it made sense to you, though, and you feel confident about them, then that's amazing. Great for you. And do those questions. Get those points. Did I lose anybody? Are we alive out there? Question in the chat, does she repeat some of exam 1 and exam 2 questions on final? 100% yes. So that's definitely going to be the case. She might not repeat the exact same questions, but they're going to be very, very similar. So when you're studying for this, go through practice the practice book, the problem book, go through any of those questions, and you can also go through your past exam questions from exam 1 and exam 2. She usually does not repeat she doesn't usually give out the final exams. Yeah, so if you know the exam 1 and exam 2 content, then like you're going to be good.
Question.
What was that?
Yeah, hi, Professor. Yeah, I want to know, in the final exam, you mentioned regular. There's some problem. It's only just a regular expression, context-free grammar, and the automaton. I mean, this problem is only involved in single of this topic or some complex problem. Like one question gonna has a regular expression and context free grammar.
So these do have to do with kind of a little bit of all of those topics because it really does go hand in hand. Um, Regular expressions and automatons are both regular languages. So even though a question like this might not have asked you to make an automaton, it could have. If you had a question that was just saying if it's a regular language, construct a regex or construct an automaton, that totally is fine. Grammars are usually just kind of separate in the sense that they can actually handle links to some extent.
So how much weight is this this easy problem gonna have in the final?
I'm sorry, I couldn't really hear you.
I mean, how much weight is this easier question gonna is in the final? Because because you just say probably the final exam gonna have gonna be okay. So according to the score, it can be 60 or 60 out of 150, right? So I mean, the either question gonna be gonna be in the half of the full score or something like that.
Well, it kind of depends on how many questions she has. So I just gave an estimate of having you need about 60 points out of like 150 to pass.
Yeah.
It really depends on how many questions she gives. She might give more, she might give less, but just expect more questions and more time than you had on the midterms.
Okay.
Yeah. So if and also that gives you a lot of freedom with these types of questions. Like if you look at these questions and you're like, "Yikes, these are really rough," because again, these are meant to be confusing. Like skip them. Don't waste time on questions that you're not too sure on. The exams are designed for you to skip around and pick the questions that you feel confident about. So, don't feel like you have to answer every single question. I'm just doing these just because, again, these are usually the tricky ones. And also, the most important takeaway is knowing when to use Pumping Lemma and when to not use Pumping Lemma. And if you do this, right, you can honestly look at a question like this, even if it's a really, really, really hard grammar. If you know immediately, wait, this can't be a grammar because there's links of 3, you can create a Pumping Lemma proof. And you can get those points without having to construct the whole grammar. Like you saw how long that took me to do that one. While this one, was an actual grammar question, maybe there was one that actually had like links between like it said that the first, middle, and last character all had to be the same, and then the length was like infinite or something. I don't know. If it's something overly complicated like this that actually had links of 3, you might have been intimidated and said, oh, how do I construct a grammar? Until you write it out and realize, wait, there's a link of 3 here. There is no grammar. Let me do a pumping lemma proof on that. So that actually relieves a lot of the work on a question like this, which is why the most important thing really is knowing to pump or not to pump. That's the question. So in the yeah?
For a pumping lemma proof, because I know you guys said that we're not going to receive the same template that we got on the second exam. So are we going to have to like write out the entire like statement like that she had as like a template in the second exam?
I wouldn't say word for word, but close enough, I would say. If you have the gist of it, then you're gonna be fine. Like, I don't think she's gonna be like, oh, you're missing like a single word here. Like, it's not gonna be that crazy. And there is partial credit, but you will have to memorize at least the gist of the proof. It doesn't have to be word for word, but it has to be close enough and it has to have the gist. If you take a look at a couple of, in the Discord server, Austin Daniels videos, he kind of goes over it in his own words too. Like, he uses the template, but he also kind of goes off the page a little bit. So if you want to hear like some more examples on how to kind of explain it, I would say to also watch those videos, since those were very helpful as well. But yeah, you will not have the template, so if you're kind of worried about that, don't worry, because out of the how many questions? Maybe like 12 or 15 questions. There's going to be a lot of questions. If maybe 2 of them require pumping lemma. I would estimate that out of all the questions that give you a choice on how to use pumping lemma, half of them might use pumping lemma, half of them might not use pumping lemma. So I wouldn't expect a whole exam of pumping lemma. That's basically what I'm saying, which is why I say, if you know when not to use it and you don't want to memorize that proof, just know when not to use it and just do the question, make the grammar. That was my strategy on the exam personally. I don't do very well with proofs, and because of that, I just straight up focused more on the questions that I could do, and I was fine. So I'm not saying, completely forget about it, but, you have room you have wiggle room with this. You can pick the topics that you are good with. So focus on what you are good with and focus on maximizing your points. You do not have to get everything. Don't just say, okay, I'm not going to do any of this and just ride on regular expressions. Maybe don't do that. But, you can basically afford to miss like a topic or 2 and still be totally fine.
Oh, as you say, some of question on the final exam, mean the question time gonna be very similar with exam 1 and exam 2, right?
Yeah, pretty much the same types of questions.
So because okay, for example, for the pumping lemma, on the for the pumping lemma in the last exam, the exam 2, the question type is totally different with I just give to you some like something like what you show on the screen, right? So that means we don't need to practice this type of question.
Right. So again, I can't really say exactly what type of pumping lemma related question there would be, but to practice them, I would really take a look at the problem book and see some of them you construct the grammar and the regex for. Others, she'll actually have the proof written out. Look at that and look at past exams. Past exams for sure will have pumping lemma on them. So I definitely think if you want to really see what they would look like kind of in like a exam environment, take a look at the exams for those kinds of questions. Okay. I'm going to get back to finishing these up. unless anyone has other questions that you want to put in the chat. Also, Rashawn, can you put the feedback form in the chat as well? Since we're almost towards the end, I want to make sure that people have the chance to fill out the feedback form. We appreciate all the feedback that you give us, and the more feedback we have, the more sessions like this we can have. So, yeah. All right, let's take a look at these last 3 questions. I'm going to just try to go through them a little quicker, just to kind of get the gist of when to use Pumping Lemma or not. And then after that, I see exam 2 was posted in the chat, so we can kind of look over that structure and kind of see kind of what's going on with that. All right, so problem 7 over here, let sigma equal A, B, C, G, and let L be exactly those strings over sigma that satisfy the following properties. All right, let's go through each of them and see which ones cause an issue with regular, which ones cause a problem with context-free. Symbols in the string occur in alphabetical order from left to right. No problem with that. Either regular, context-free, that's not a problem. We did that on the previous question. The number of A's is equal to the number of B's. Okay, that immediately, that's your link. That is a link. A to the n is equal to B to the n, right? There's a link between them. Immediately, this is not regular. But this is context-free, so we're fine. All right, the number of C's is equal to twice the number of B's. Okay, we have another link. The number of C's is equal to twice the number of B's. So 2M, and then B is M. Okay, now immediately also, we have a bit of an issue here as well, before I even go to the number of G's. There's going to be a link between the B and the A, but also a B and the C. And this has to be in alphabetical order, meaning that this is going to end up looking kind of like this, right? So there's going to be a link here, but also a link here. The number of C's is equal to twice the number of B's, right? Okay. Well, this means that the number of C's is equal to twice the number of B's, and that also means that if this is A to the n, this is B to the n, then this is essentially C to the 2n, because remember, these guys are linked together and this is linked together. Oh no, what do we have here? A 3-way link. This is a problem. So this is immediately going to be using Pumping Lemma. This is not context-free. So that's how you would identify one like this is immediately not context-free. And I'm not going to go through the whole proof in the essence of time, but what's the gist here? You have a characteristic property, okay? The number of A's has to be equal to the number of B's, and the number of C's has to be 2 times the number of A's and B's, essentially, in order to get this to work. Okay, so we would define our pumping window, right? And our pumping window is essentially going to be way too small, right? We know it's going to be less than the length of this string. So it can go between 2 of these guys, 2 of these consecutive parts. It could either stretch here or stretch here. It can't stretch the whole length of the string because it's not big enough. So because of that, I pump this or I pump this. I can't pump both. And when I pump one side and not the other side, we have an issue and our characteristic property is broken. So that is going to be the gist of that question. Okay. And the next one here, problem 17, consists of exactly those palindromes whose length is divisible by 4, but the last symbol is G. All right, so this is identical to the problem that we did before, right? Except the only difference is instead of a C, the last symbol is G, so we would literally just replace the CAC with GAC and GEG. Because again, last symbol is G, that means also the first symbol must be G for it to be a palindrome. Same thing. And lastly, this problem here, exactly those strings over sigma that satisfy the following properties. All right, let's go through each one. Symbols in the string occur in alphabetical order from left to right. No problems there just yet. The number of A's is less than the number of B's. Immediately, there is a link. We know that's less than. This means this is not context free, right? So if this was asking for, I'm sorry, this is not a regular, not context free. So if this was if this was asking for, if it is regular, make a regular expression, and you see this, you immediately would have to use pumping lemma. Otherwise, you would construct the grammar, because everything else is fine here. The number of C's is divisible by 4, that's fine. The number of G's is divisible by 3, that's totally fine. So this is totally fine to make a grammar for, but not a regex. So again, if you were to create a proof, if this was not regular, you would just say that the number of A's has to be less than the number of B's. You construct your pumping window. You pump the A's or you pump the B's. Boom, characteristic property broken, and you basically proved it. So in a case like that, that's the way you want to kind of think through these types of questions. All right, so there was a request for... Yeah, sorry, what was that?
Sorry, are you done with the context free and the regular? Because I posted some Pushdown Automatons. People are asking for an example to go over that. So whenever you're done with this, would you please go over the pushdown?
Yep, absolutely.
Thank you.
No problem. Okay, so we'll do pushdowns as next topic. Okay. All right, so what do we got over here? We have our pushdown here. So we're creating a regular expression that represents L5, which is the language represented over here by this pushdown automaton. And we have the following sigma and tau. So again, this is what we're reading. This is what we are writing. And then we have our final state is V. So pushdowns are very similar to Turing machines, except that you're kind of following the stack format. So with a stack, we know it's LIFO, last in, first out. Think of it as a stack of pancakes, stack of plate. You have to get the top before you get the bottom. So in a case like this, right? Okay, we want to essentially take a look at our starting transitions first. We have Q is going to either have a B or an A. And this is going to either read an A or read a B, and it's going to either move to state X or state Y. So if this was creating like an automaton based on this, right? Well, we're making a regex, but we know this would essentially branch off in two separate directions, a path for X and a path for Y. Okay, so we just read an A or a B, right? Because we know that this over here is saying we're not pushing anything onto our stack and we're not popping anything onto our stack. So I can choose to have, think of it like a tape, from Q to X, Q to Y. This is a B and this is an A. Okay, then let's start with X as our first one, right? I can look here and I can look here. The first one is going to say X, I'm going to read an F, right? And I'm going to take a look at what I'm gonna push to the stack is going to be the word empty. So we know that it's, again, last in, first out, right? LIFO. So it's gonna pile in E, M, P, T, Y. So it's gonna kind of look like upside down, essentially. Okay, so I know that I had to read in an F in order to do this. So I'm gonna have an F over here. And this is going to end up bringing me to state T. Okay. Now, I also have the choice to have this over here, which says read nothing, and read nothing, pop nothing, push nothing, but go to state V. And state V is a final state, right? So essentially, if I didn't go to this over here, I could have just chosen to go to V as a final state. So with that being said, right, okay, so with that being said, technically, I could have ended the loop just by having a single B. So I know that part of this is going to have a B. Okay. Now let's continue the path, right? So if I'm in state T, I have the choice of all of these guys over here, right? And this is saying that I'm going to be popping each of these guys if I have the corresponding character, right? But the problem is that I can't really do that because I can't do it in any order is what I mean, because I have to do it in the reverse order that's over here. So I have to pop the Y off first, right? Then I have to pop the T, then I have to do the P, then I have to do the M, and then finally the E. So all I have to do now is just kind of write down the characters that would let me do this, right? Because I want to get to myself to get an empty, literally an empty thing here. So to do this, right, I want to pop off the Y, and to do that, I need a G, since that's what I got here, and this lets me loop back to T. Okay, then what's the next one? Well, to T, I need to get a B, loops back, then I need a P, that's going to get me an F, and M is going to get me an H, I'm sorry, G, B, F, H, and then finally E. This I need a C for. Okay, so it looks like a bunch of gibberish right now, but what we can do essentially now is loop back to X. And what does X allow me to do? Well, at this point, my stack's empty. So I can choose to either go back and accept on an empty stack, or fill it up with the letters again, go to state T, and empty them all again. So that means I can loop this as many times as I want. So this is going to be one of my cases. Now the second case is if we ended up going to a Y. And for the Y now, right, Y is extremely similar. I have a case that has a POT putting into the queue, and I have a case that just simply accepts it, right? So we know if we have an A with nothing else, we're going to accept it. But if I wanted to put the POT in the stack, It's going to look like this, and then I'm going to go to state S. State S is this over here. Now I have to pop the corresponding characters. So just like before, I have to start with a T, which I need a B to get rid of. Then I need an O, which is an A to get rid of. And then I need to get rid of the P, which I need an F to get rid of. Right? And oh, I'm so sorry. I forgot. To get to state Y in the first place, I needed an H, right? Since this H brought me to state S, and then I can choose to get rid of them with the B, A, F. Okay? And then I get back to my state, and I can choose to just cycle this as many times as I want, just like before. So these are going to be my two regex that I can essentially go between them. So I can choose B and then the loop FGBFHC, or I can choose A, HBAF, and this would allow me to accept on that. So that was a fun problem. So the main key here is we had two separate paths to go down, and we can push things, right? We pushed empty, but we have to pop it in a specific order. If I don't pop this in a specific order, by the way, the question itself didn't ask for a regex of rejecting, but basically anything that is not in this order, you will not be able to make any progress on, right? And the only way I can get back to my final state V is if I have a completely empty stack. Notice, I can't have anything in there in order for it to accept. So I have to do things precisely in this order. Otherwise, I can't reach this. And yeah, I can do this as many times as I want to. Like, I could literally go back and forth, fill it, empty it, fill it, empty it. That's why, just like how we did regex in the past, it's this sequence of characters with the star around it. The F fills it, these guys empty it. The H fills it, these guys empty it. Questions before I go to the other one? Okay. So this one looks a little bit smaller, right? There's not as many states going on here, but it's still going to be the same policy, right? So we got our stack and we got our tape. I'll put my tape down here. And I got my stack. All right, so we start out at Q, right? So what's going on with Q? Well, if I read a C, I have rainy, and if I read an H, I have day. Both of these guys get me into T, though. Okay, so I'm going to break this down into two paths just like before. The case where we push a rainy and pop a rainy, and push a day and pop a day. That sounds really weird. Non-CS major hearing this conversation would definitely find it interesting. So let's say I went for C first. Okay, this brings me to T now. And this is going to push rainy onto my stack. Now that I'm in T, I have to pop them in the correct order. Meaning I have to pop the Y first, and I do that with a G. Then the N, I do that with an H. then the I with an F, then an A with an A, and an R with a B. So G-A-F-A-B. Okay. All right, cool. It's empty. Now, notice this B is the one that brings me back to Q, just like before. And at this point, I can choose to either accept, because, right, Q is an accepting state, right? We know that. Or I can choose to go to H, right? And H now, if I decided to do Q to T on an H, this would just simply be push D-A-Y if I have an H that I read, and pop the Y with the G, the A with the A, and the D with the C. G-A-C. Okay. So that means that, similar to last time, right, I can choose to do C and then these guys to pop the C, or I can choose to do an H and these guys for the day. Each of these guys, right, it could be this or this, and this whole thing can be in a star, because I can choose to do these as many times as I want, given that I have a Q here. And if I choose to do them 0 times, I'm just left with an empty stack, and I can accept because F is a final state. Q is F, our final state. So with that being said, I can just literally say the star is 0 and do nothing, or choose this set or this set. But notice that they have to go together in this order. Otherwise, we have a problem. And we can't pop everything. And if we can't pop anything, we can never get back to Q. And if we never get back to Q, then we can never accept. And the world is over. Oh no. So that is the end of that problem. And do you have any other questions?
So yes, there are also algorithms for this. Wait.
I texted you, you didn't get back to me. I'm on a meeting right now.
Wait, you can hear me, right?
Sorry, what was that?
Sorry, wait, can you hear me?
Yes, I can hear you.
Oh, because I know there's algorithms, but are they similar to Turing machines?
Yes, so pushdowns are identical to Turing machines, pretty much, except that you're just dealing with the stack. So they're slightly easier than Turing machines.
But I just have, if I get familiar with Turing machines, then I could get familiar with the proof for pushdowns.
Yes, that's correct.
Okay, because I didn't attend some of the lectures because I was thinking I needed to be busy with something else.
Yeah, no, that's understandable. Listen, things happen. But the key is if you can do these problems, practice them a lot, then you're going to be fine, right? There's people that never attended class and they practice a lot of these problems and they do very well. And there's people that attend class and do no problems and they do really bad. So it really comes down to how many of these problems that you do, if you understand them a lot. And yeah, the more practice you do, the better that you're going to get. Practice really does make perfect when it comes to this stuff.
Oh, I see. But I encountered there were a bunch of algorithms on the second exam, and if I don't want to be unprepared with that again.
Right. Usually they have the algorithms at the end of the problems for those.
Yeah.
Yeah, I'd say if anything, the best way to prepare for those is kind of just see the recurring theme for them. Unfortunately, we're kind of out of time here.
It's okay, but But I do think like there's not many more days for review, right?
Yeah, this is the only one that we have scheduled. There are going to be some tutors available next week a little bit, but it is kind of limited. I'll be honest though, at this point, I wouldn't dwell too much on the algorithm questions. I really would try to focus your time more on the stuff that you can maximize your points on. For instance, for Turing, actually, even for this question, does it say how many points? Oh, these are just from the problem book. Okay, but think about on the Turing machine problems. They were like 15 points, give or take. That's a lot of points. Even if you don't do a couple parts of them, you can still get a lot of points. So I would really recommend look through these practice exams. Take a look at the point structure and create a plan. Go through the questions that you know for sure you can get right. You might be a whiz with regular expressions. Do the regular expressions. Calculate how many points you got. See if you passed, or whatever you needed to pass, or get whatever score that you wanted. So if you do that, then honestly, you're going to be good for that. It's not so much of knowing everything, it's just knowing enough to get the score that you want, basically.
Okay. Well, maybe I'll check to see who's available. But it will be pretty busy.
Yeah, unfortunately, it is kind of limited with the hours, but yeah.
Okay, thank you.
Right. With that, are there any other questions before we conclude? Regex, please. We did do a couple of regex, but is there a specific question that you have? Okay. Yeah, we did do a couple of regex before that. They weren't necessarily regex in the sense of like stuff that you'd see from exam 1, but it used what we learned from exam 1 to go over it. But in terms of regex, honestly, if you know how to convert between any of the other data structures into a regex, then you're pretty good. I mean, look, these required regex, right? Even though it looked more like a Turing machine, because it was like more of a pushdown question, these are regex, right? It's a B concatenated with the rest of this stuff that has to be in that order. Or here, right? It's this or this. And the whole thing is starred because, again, it could be done 0 or more times. So, honestly, by doing this, we had practiced some regex. But if there's still something that you're not too sure on, oh, perfect, there's a question. Oh, okay. Let's do this question quick then. This is definitely a good one to go over. So this is one of those pure regex questions. I can guarantee a question very similar to this will be on the exam. And that's great because this is usually pretty easy points, right? Even if you don't do the whole thing. I mean, listen, there's a lot of stuff going on here. Usually there's a couple of these that are very straightforward. So I wouldn't stress too much about getting every single one here, right? Listen, even if you get, this is 12 points and you have 1, 2, 3, 4, 5, right? So even if you do just a couple of these, right? Even if you just do like half of them, you're still getting 6 points and you're still doing good with them. So let's do these quick. L1 is exactly those strings over the alphabet that do not begin with A and do not end with G. So let's think. We have not beginning with A. So something that is not an A is going to be a B, C, or G, right? And then not ending with G means that all the way over here is going to be an A, a B, or a C, right? In between, I could have pretty much anything that I want. this is my main case, right? But now I got to consider a couple of edge cases with these questions. That's the main picture. Because, well, yes, this is part of the answer, there's also other things that you have to keep in mind. The only limitations is it can't begin with A and does not end with G. Okay, what if I had a string that was nothing? A lambda doesn't begin with G and it doesn't end with, it doesn't begin with A and it doesn't end with G either. It doesn't begin or end with anything. That's fine. What if I had a single character that was a B or a C? Neither of this is the beginning and the end of my string, and neither of them start or end, right? That's totally fine. So both of these can totally work for something like that, right? Now, what about if I had a string that had, right, let's see, we have lambda or B or C, and this is another case too, right? This is the case where we don't begin with an A, non-G, anything I want in between, right? So now what about if I had a case that, wait, what else did they have for this? B or C or G, anything I want, A or B, that or that. Oh, okay, so I got all of them. Okay. It was just a little different than in the order, but that's fine. So the key here is you think of the obvious case. This is your obvious case. You know, okay, non-A, non-G, whatever I want in between. Then I got to think of my non-obvious cases, my edge cases. I look at what is mandatory here. There's a character here and a character here. Well, the only thing that I can't do is begin or end with the A or end with the G, right? So because of that, right, what about a character that's just a single character? That can totally work. So I want to think of single character cases, and I want to think of a no character case, just the lambda. So that's what we are doing in a case like this. So this can make it tricky, these edge cases, but if you just walk through them like that, then you should be totally fine. Okay, let's go through B. Exactly those strings over the alphabet A, B, C, G, whose length is not divisible by 3. Okay, so not divisible by 3. Remember when we go back to the modulus, right? I have a choice. This can either be equal to 0, 1, or 2. So in a case like this, right, we can have a case where it's divisible by 3, right, and it's equal to 0. Or I could have a remainder of 1 or a remainder of 2. So remember when we went back to that example of when something was divisible by a number, right? If we had the example of 2n plus 1, I had a number that was 2n, and then I just added 1 to it to make it no longer divisible by 2, no longer even. I could just make something divisible by 3 and add 1 or 2 to it to no longer make it divisible by 3. So how would I do something like that? Just to save time in the instance of time, I'm going to say sigma is equal to A or B or C or G. So this is just literally all of our characters. So otherwise it's going to get very long. So now I can say, to make it divisible by 3, I choose 3 characters. Sigma, sigma, sigma. Okay. Now I can choose to either add 1 to it, making it no longer divisible, right? Or I could add 2 to it. So the way that I can do something like this is say, all right, well, I want multiples of 3. And then I want to say, add 1 to it. Or I can choose to add another 1 to it. At the very minimum, I need one of these guys. This guy over here is optional. To say if it's optional or not, right, I don't want to say a star because a star can have as many times as I want. So I'm just going to say this or lambda. And what this is saying is pick a character or don't pick a character. At the very minimum, I'll have a character here. Now, if this was saying I did want it divisible by 3, right? Or if I wanted it divisible by 3 or 5, let's say, I don't know, I could do this as many times as I want, right? I could have this as many times as I want. And this is a little trick that you can do to say, okay, well, I need it to be, instead of 2n, right, now it's going to be 3n plus 1 or plus 2. At the very minimum, I need 1. Or I could have 2. If this was a larger number, maybe I would have had another set of this, and another set of this, and another set of this. That's totally fine too. And you'll see, this is exactly what we have here. This is sigma, sigma, sigma. This is a set of 3 sigma with a star. This is a mandatory sigma to have that at least plus 1, and then an optional sigma. It's sigma or a lambda, because I can choose to just eliminate this, and then it's just plus 1. So that can make things a little tricky, right? Now, I could also have chosen to, I could have, no, actually, this is probably the better way to do it. Because again, the problem with star is that if I just had straight up any star, I could be any length, and that could cause problems. We don't want it to be any length. We want to control it. We always want to have a group of 3, and then immediately make it no longer divisible by 3 by adding a 1 or a 2. Notice how these don't have stars on them, because otherwise I could have easily made this back to 3. Okay, let's do C now real quick.
Miss Lauren, for number B, so if it was something like, if it's not divisible by 4, we have 4 in the first group that's in the star, and then it would be plus 1 that's mandatory, or plus 2 or plus 3.
You got it.
Okay.
Just like that. Yeah, so that's a great way to move around the problem as well. So now you can kind of see how you can just essentially do this for any divisibility or non-divisibility that you need. All right, so now we have over here part C. At least one of the 4 letters occurs exactly once. So we have exactly 4 cases to take into account with this. There's a case with the mandatory A, a case with the mandatory B, a case with the mandatory C, or a case with the mandatory G. So quite literally, I'm just going to do that. Right? A, B, C, G, and it says exactly once. So that means I can't just say, oh, have anything I want here, anything I want here. I have to actually limit it a bit. I have to have every non-A here, non-A here, every non-B here, A or C or G, A or C or G, every non-C here, A, B, G, A, B, G, and every non-G here, A, B, C, A, B, C. Okay, and this makes sure that I can choose between any of these guys, right? So this says exactly 1A, exactly 1B, exactly 1C, exactly 1G. I don't have to worry about edge cases here because at the very minimum, I need to have a string that has A, B, C, or G, a single character. All of this can be optional if I choose it to be because of the star. So I don't have to worry about edge cases there. So that would be my answer for that guy. So the trick with these guys is write down the mandatory parts, right? And then from there, go into what you can technically add, sprinkle onto it. So the mandatory part was at the very minimum. I needed a single A, B, C, G, and the sprinkles were every non-A for the A, every non-B for the B, every non-C for the C, etc. right, so that was C, D. The number of A's plus the number of C's is odd. Okay, going back to our 2n plus 1, right? So that means that I'm going to have a set of A or B concatenated with another A or B, right? This is going to go in parentheses. Okay, that's totally fine. And then I have to have another A or B here. This allows me to have the number of A's plus the number of, oh, that's supposed to be C's. I was doing this the other way because I don't know why I thought it was B. A or C, A or C, A or C. It's same thing, right? But now, here's the thing, right? This is allowing the A's or the C's. This is the absolute mandatory part. But now I have to include, what about the B's and the G's? I can put as many B's and G's as I want anywhere sprinkled throughout this. So this now allows me, oops. This essentially allows me to now sprinkle as many B's and G's as I want. So I can just do as many B's or G's anywhere that I want. I can put a B or G here, right? I can put a B or G here. I could put a B or G here. I could put a B or G here. I could put a B or G here, right? And remember, we want this to be odd, right? So this whole thing should also go in a star. So I can have as many B's or G's as I want, and actually all these guys should probably also have stars too to be on the safe side. We really don't care about the B's or G's. It literally looks like a bug. Think of it, you could just put the bug wherever you want. We essentially just sandwich them in between everywhere else after we put our main attraction in. And finally, part E, let L5 be exactly those strings over the alphabet where at least one of the 4 letters occurs at least twice. Okay, so remember this one occurs at least once, or actually occurs exactly once. We're going to do a very similar thing, except this time, because it's at least, instead of limiting it and having non-A's here and here, now we're bringing back the A's. So once again, I'm going to have sigma is equal to A or B or C or G. You can do this on your exam, by the way. And I know it can be a lot to write out. If you want to shorthand it like this, you just have to define what this is. I use sigma just because it is defined as the alphabet, right? So that's fine. Otherwise, you can say like X is equal to that or some other thing. Just as long as it's not within this here, like you don't want to say lowercase a is equal to this or even another lowercase letter. So if you want to shorthand it, that's totally fine. Do that, but make sure you define it because she's not going to know what you're writing unless you actually define it. Anyway, so it's when at least one of the 4 letters occurs at least twice, right? So I have to have a case for the A's, I have to have a case for the B's, the C's, and the G's. And all I'm going to just say is, actually I'm going to say this is going to be that star, since all I'm going to do is just put the sigmas in between. And all this is going to let me do now is just say that I guaranteed an A and an A, B and a B, a C and a C, a G and a G. I don't care about anything else because notice it said at least twice. So this is totally fine to have another A here if I wanted to. The previous example said only exactly 1, right? Because that's why we had non-A's here and non-A's here. Otherwise, we could have just had an A here, right? If it didn't say exactly, if it said at least. So be very mindful of least, at most, and exactly equal to, because those will get you. that marks the end of that question. So, takeaways. Watch out for those edge cases. They mostly appear when you don't have stars around things. For instance, this first one over here. We were able to create edge cases for when there was no characters with the lambda and exactly one character with the B and the C. So watch out for those guys. And then otherwise, create your case, create what's mandatory, and then fill in the blanks with the sprinkles. That's practically it. How are we feeling out there? No problem. That was a good question to go over. Definitely going to be one like this on the exam, I would say. So definitely a good thing to go over. Oh, yeah, absolutely. Is that good? Perfect. Okay. Yeah, and by the way, this was recorded. I also recorded this on my own as well, just because it does take a day or two for the Learning Commons to upload. Just because like it goes through like the I guess Learning Commons account for Zoom, so it kind of takes a while to process. So just so you guys have it, I just have a video on my end as well. But yeah, you guys can access this either through the Discord server on the YouTube link that I'll have uploaded maybe in an hour or two. Otherwise, yeah, stay tuned. It'll be on the Learning Commons YouTube as well. Like and subscribe, guys! Alright, with that being said, any last minute questions? And please fill out the feedback form. Alright, well, with that, best of luck on your exam. We'll keep it open for a few minutes for you guys to fill out the feedback form, and yeah, thank you very much for attending.